The last trend is ionization energy. So ionization energy is the energy required to remove an electron from an atom or an ion. So I have a couple just equations showing the electron being removed. So M represents a metal because metals lose electrons. So M is the neutral atom, goes to M ion plus the electron. So it shows that there's been one electron removed. So the first ionization energy is the amount of energy required to remove that first electron. And then the second ionization energy is the amount of energy required to remove the second electron. So magnesium would be a great example. Magnesium likes to lose 2 electrons, but there's a certain amount of energy required for the first one and then a certain amount of energy required for the second one. So the general trend is that as we go across the period left to right, is that the ionization energy increases. So it kind of makes sense because we know that metals, which are on the left side, like to lose electrons. So it's not going to take a whole lot of energy to remove electrons from the metals. But as we go over to the nonmetals, we know that the nonmetals like to gain electrons, not lose electrons. So, and we also know atom size is decreasing as we go from left to right across the period. So those electrons are being held more tightly because the atom size is getting smaller. It's going to make it a lot more difficult to remove those electrons on the nonmetal side. So that's why the ionization energy increases. Now, going down a group, we know that the size of the atom increases, and we know that if the atom is increasing, those electrons are getting further and further away from the nucleus, and it's a lot easier to remove one of those. So that's why the ionization energy decreases. So I just gave you this chart. It's not in your book, but I think it's interesting. It has the different ionization energies, and you don't need to memorize those numbers or anything like that. I just wanted to show you this. But sodium is a +1. It likes to lose 1 electron. So the ionization energy for it to required for it to remove that 1 electron is 496. So I just want to do this real quick for you. So sodium 1s2, 2s2, 2p6, 3s1. So that's sodium's electron configuration. So the 1 electron that it's losing is this one right here, right? Because we know that valence electrons are involved in bonding. So it's losing the 3s1. Well, if we tried to remove another electron, then we would be trying to take an electron from the core electrons, right? When we get into shell 2, those are the core electrons. Well, let's look at the energy difference here. So it takes 496 kilojoules per mole to remove that first electron, and then we jump to 4,562 because we're trying to remove a core electron, and it's going to take a whole lot more energy. So then you can see with magnesium likes to lose 2 electrons. So for the first ionization energy, it's 738. The second ionization energy is 1,451. And then when we start to dip into the third, which is going to be our core electrons, the energy shoots up. So anytime we're trying to get those core electrons, it's going to take a whole lot more energy. So again, you don't need to remember those numbers. I just wanted to point that out. It takes a lot of energy to remove core electrons. Okay, we're not going to cover the last 2 slides, so you can ignore those. But let's go ahead and do the rest of the questions from your worksheet. Actually, I don't need to write. So number 9 says, which of the following elements has a larger radius? Well, I'll go back to this. Wait. I'll go back to this one. Okay. So does beryllium or calcium have a larger radius? So you can see as we go down the group, atom size is getting bigger, so calcium's going to be bigger. So circle calcium. And then bromine or gallium. So bromine and gallium right there in the same period. So gallium's bigger because as we go across the period, it gets smaller. And then chlorine or sulfur. So again, going left to right, it's going to get smaller, so sulfur is going to be bigger. And then we have tin and bismuth. So the diagonal ones are kind of difficult. I'm not going to give you a diagonal one like this on the test, so don't worry about it. But bismuth is larger because remember when we go down the group, we get into a higher shell number. And then carbon or fluorine. So carbon's going to be bigger because we're getting smaller as we go from left to right. Okay. Then let's go to this one. Number 10. Which of the following elements has higher ionization energy? So titanium or vanadium. So going left to right, ionization energy increases. So vanadium would have a higher ionization energy. Phosphorus or chlorine. Chlorine would be higher. Magnesium or strontium. So as we go down the group, ionization energy decreases, so magnesium will be higher. Iron or osmium. So iron would be higher because osmium goes down the group. And boron or bromine. So again, that's kind of a weird one. I won't give you one like that on the test, but boron would be higher.